Okay, now this is the last video in this lesson, so as we look at this, we will now be applying all of the different properties and theorems to solve these questions. So there's 3 examples that we can see of combining the different principles that we've seen so far. So in this example, they're asking you to find angle AOB. And again, I have my tangent line, so I'm always thinking, okay, my radius and the tangent meet at a 90-degree angle. And I notice that I have 2 radii, so that means that this is an isosceles triangle. So they're asking us to find angle AOB, so that's going to be this angle. So immediately I'm going to think, okay, this has to be my 90-degree angle because a tangent meets a radius at a 90-degree angle. So to find this small interior angle, we can do 90 minus 58, and we end up with, this is 32 degrees. This one's 32 degrees, and that's because tangent meets radius at 90 degrees, okay? So if this angle is 32 degrees, then this one also has to be 32 degrees because isosceles triangles. So 32 is OAB because isosceles triangle. So then we know that a triangle has to have 180 degrees, so we can do 180 minus 64, the two 32's combined, and we end up with 116 degrees, and that's because sum of angles in triangle equals 180 degrees. So there we go. So we have used a few different principles here. We used a tangent meets the radius at 90 degrees. We used an isosceles triangle, and then we used the sum of the angles in a triangle is 180. So if we move on to the next question, I notice that I have a situation that they give me the angle at the center. So we know we can find this angle at the circumference, which is exactly what they're going to ask us. Find an angle RPQ. That's this one. So we know the angle at the center is twice the angle at the circumference. So we can do 206 divided by 2, and we get 103 degrees because angle at center equals, we could say 2 times angle at circumference. And I abbreviated kind of what I got there, but we've given the explanation. Okay, so we know that this is 103 degrees there. And then they want us now to find angle OQP. So we're talking about this angle. Now don't be confused, this is not a cyclic quadrilateral. For this to be a cyclic quadrilateral, this point would have to be down there. It has to touch at each of the vertices. But what I do know is it is a quadrilateral, a fully sided figure, so that means it has to have a sum of 360 degrees. Well, firstly we can figure out what this angle is because this complete circle has to be 360. So we can do 360 minus 206, and we come up with 154 degrees. Oops, 154 degrees because angles in circle equal 360 degrees. Now we can just see what we're missing then from 360, the total of all of the angles in the quadrilateral. So we can add those up. So we have 103, 45, and 154. We can add up those angles. We get 9, 12, 10. We have 302 degrees that we have already in this. So we can do 360 minus 302, and we come up with 58 degrees. And that's because quadrilaterals, whoops, help if I put an A. Quadrilaterals are 360 degrees. So again, so we've applied a few different things. We've applied this idea of the angle at the center is twice that at the circumference, and then we have done the angles of a circle have to be 360, and then the angles in a quadrilateral also have to be 360 degrees, so to figure that one out. The last one we have here, immediately I'm thinking same segment because of the shape alone, and I see that we have the diameter given to us. So I'm also thinking we have a semicircle, which means we have a right angle. And they want us in this to find angle ABD. So that's this angle here. This is 71. It's a little bit difficult to see maybe from your view. So if we have a semicircle, that means the angle across from it is going to be 90 degrees. So that's going to be a 90-degree angle here. That's 71. We don't know what this one is, so we can figure it out. We can say find out what we're missing. We have 161. We need to be 180 to be a complete triangle. So that means we have, oops, I didn't do that right, 19 degrees. So this one's going to be 19 degrees here, and that's going to be because triangles are 180. And we also, for this right angle, use the fact that there is a right angle in a semicircle. Okay, so then to figure out this angle over here, this B one, we can see that these angles are in the same segment. We began at A, went to C, landed at D. We begin at A, go to B, end at D. So we began at A on both of them and ended at D. So we have the answer is 19 degrees because angles in the same segment are equal. So you can see it's not so difficult to write out the explanations as you might have thought. Just try to say why it is that you can figure out what you're doing as you go. So that's going to be a clearly logical explanation. So you can see we've applied all the different kinds of concepts we've had, not all of them in these three examples, but within all the examples that we've looked at, because we've looked at the cyclic quadrilaterals, we've looked at the interior and exterior angles of those, and we've looked at all of them at one point or another. So now you should be able to apply these to the questions in the lesson and then on to the examination questions.